Welcome back to our Solid Principles series. My name is Darlington. Today we're tackling the Liskov Substitution Principle, or the LSP. The LSP states that subtypes should be substitutable for their base types without altering the correctness of the program. In simpler terms, if you have a class that uses a parent class, you should be able to replace the parent class with any of its classes without breaking the program. That's the basis of the LSP. Why is it important, you may ask again? The LSP ensures that inheritance hierarchy is well designed and that your subclasses behave in a way that's consistent with any of their parent classes. This leads to more reliable and predictable code. Let's see an example here. We have a bird class and we have a penguin class that's a subclass of bird. Here in the penguin class, we override the behavior of the fly method and throw an unsupported operation exception because a penguin doesn't fly. This obviously violates the LSP because a penguin cannot be substituted for a bird without breaking the program. As explained here, the fly method in penguin throws an exception which might not be expected by the code that uses the bird class. Okay, let's look at an approach that can fix this. A better approach would be to have a separate interface for flying birds. So let's introduce a new interface. Call it flyable, and flyable has a single method called fly. Let's go ahead and clean up some of this code so we don't need this fly method in bird now. And we'll need to clean up the penguin class as well because it can no longer override the fly method because it doesn't exist in bird. So now if we want to add a new bird, say eagle, that actually flies. It will still extend bird because it's a bird and also implement flyable because it flies. And we obviously need to realize the implementation of fly. Okay, let's run through the changes again. We still have a bird class. We have a penguin that extends bird, so it's still a subclass of bird. We also introduced a flyable interface so that birds that actually fly can implement this interface and realize the implementation of the fly method. And we now have eagle, which is still a bird, so it extends bird, but also flies, so it implements flyable and realizes the implementation of fly. So now only birds that can actually fly implement the flyable interface. This adheres to the LSP and ensures that our inheritance hierarchy is sound. That right there is the Liskov Substitution Principle. It's a crucial principle for designing robust and maintainable inheritance hierarchies. Stay tuned for the next video where we'll explore the interface segregation principle. And as always, if you found this helpful, please like and subscribe. See you in the next one.